everyone, welcome back to Learn DSA with Sakshi. In this video, we dive deep into the basics of linked list in C. You will learn the core functions of linked list like insertion, deletion, and traversal. We'll also discuss the call by value versus call by address and what is exactly it is. And then we also discuss some pointer terminologies using the linked list and what they actually mean. Finally, we write a short C program to check how much memory a node takes. This video is a perfect for beginner who want to build a strong foundation and in pointers and linked lists. So let's get started. So today we are going to cover these four topics. So first is the basic linked list operations like the insertion, deletion, and traversal. Then we are going to see what is call by value versus call by address, and then some basic terminologies of the pointers. And then at the end we'll write a small code to check the size of the node. So let's start with the linked list operations. For this, I'm going to drawing the functions of linked list, which function we are actually implementing in our linked list code. So I just draw a block diagram of it and then we'll further proceed. So we divide the functions of linked list in three parts. We'll write LL instead of linked list. And we divide this function in three parts, as I said, insertion, then deletion, and then for traversal. Insertion, deletion, and then traversal. Further, insertion function is divided in three types. So first one is the insert at first, then inserting node at the end, and inserting at anywhere between the node. So from this, we write the function name as insert first, insert last, and insert at position. So last, and then insert at position. And similarly for the deletion also, delete first node, delete last node, and delete any between node. So delete first, then delete last, and delete that position function. So these are for the deletion. And for the traversal, we have two functions. First is the display function, and second is the count function for counting the nodes in the linked list. So this is the representation of the functions we are going to implement in our linked list code. Now, the insertion and deletion is called the call by address function, and the traversal is called the call by value function. What is call by address and call by value? We are cover in the next slide. So these are the by address function, and these two are the call by value function. So this is the representation of the 8 functions which we are covering in the code of the linked list. So let's move to the next topic. Insertion and deletion function are called the call by address function because this actually modifies the linked list when we want to insert or delete a node at some specific position or first or at the end. It affect the linked list. So these are called the call by address function, and call by value means is actually don't modify the linked list. In this we have display and count function. Display is for just displaying the linked list, and count for taking count of the nodes of the linked list. So it doesn't actually modify linked list. So these are called the call by value function. Now we are going to see call by value versus call by address. Let's understand this concept with a very simple example. Imagine you have a house key. Now you give your friend a copy of that key. That's what we call the call by value. Your friend can use that key to open a door, sure, but they cannot change your original lock, right? Because they don't have the access to a real lock, only a copy of that key. Now, on the other hand, imagine you give them direct access to lock itself, the actual lock that's installed in your door. That is called the call by address. Now, they can make real changes. They can replace the lock, remove it, or add another one because they are working on the real thing, not a copy. So that's is the real example. Now let's relate this to the C programming in linked list. Now let's say if you have this function, so you have this function, right? Then you are just passing a copy of the head pointer to a function. This is called the call by value. Any changes made this copy won't affect the original head pointer inside in the main function, right? But if we write struct node, struct node star head instead of the struct node start head, then we are passing the address of the head pointer. And this is called the call by address. Now, inside the function, if you update head, it actually update the original pointer in the main program. Let me give you a specific example. If you write a function like void insert struct node start head, right? And in that you try to insert a node and change it. But this won't work because you just change a copy. After the function head, your original head is still in the same, but you don't do this. Instead, if you do the void insert, then struct node head, then when you update head, it changes the main function too because you are working with the actual address of the pointer. So So remember, use call by address when you want to modify the linked list structure, insert or delete nodes, and use call by value when you just want to display or count and don't want to change anything. So this is what I actually write here. So I hope you understand the call by value versus call by address. Now let's move further. Now let's learn a pointer terminology as it related to linked list. So first, what is node? A node is a structure that represents an individual elements in a linked list. A node consists of the two components, data and the next. The data is a value or the data that node holds, and the next is a pointer that points to the next node in the linked list. Then move toward the PNODE. PNODE means pointer to a node. A PNODE is simply a pointer to a node. This pointer is used to reference and manipulate node in the linked list. To access the data inside the node, we use PNODE data, and to move to the next node, we use PNODE equal to PNODE next. So we'll discuss this later when we write the code. Then PP node means pointer to pointer node. So a PP node is a pointer to a node. It is typically used when you need to modify a pointer to a node, such as modifying the head of the linked list. So these are the basic terminologies of node, pnode, and PP node. We'll discuss this in details when we actually use it and write in your code. So these are the basics of the pointer nodes. Now we are actually doing the coding. We are going to write the first code, the code to check the size of the node. So let's get started. For this, I am opening my VS Studio. From here, open the folder separate, make a separate folder for this series. So I made it. I just open it and name the file. So I name it node size.c. So yeah, we are opening file. Now just let start writing the code. So hash include just yeah. Firstly, I'll write the code and then I'll explain to you. So the main function. So this is the code for size of the node. So just save it. Now let's understand the code. We are including stdio.h file, header file. This is for the basic input and output, and we also include the stdlib file in case we want to use the dynamic memory allocations like the malloc later. So we both include these files. Then the most interesting part here is the pragma pack one. What does it do? This directive tells the compiler not to padding the structure. Means normally compiler adds some padding style between structure members to align them properly in memory. So this make access faster but increase just the size. But by using Pragma Pack 1, we are saying, hey compiler, pack everything tightly. Means don't waste the memory. So that's why we use the Pragma Pack 1. Now let's understand the actual structure from here. In C, a structure is a user-defined data type that allows you to group variable of different types together under one frame. So here we are writing struct, then name of the structure is node, then in curly braces we define its members, and then a semicolon. So this is how a typical structure we write. So this define a structure called node, which will be used to build a linked list later. And these are the members and int data. This will store integer value like 10, 20, and integer. And struct node start next is it is an pointer to another node structure. It helps one node to it helps to link one node to another. The basic idea behind the linked list. So this is a basic structure we are defining here. And from int main, the execution of any C program starts from the int main function. Then in main function, we write struct node object. So we are defining the object of that structure node, which we define here. And we are declaring a variable object of type struct node. This means memory will be allocated to hold both data and next. Then we print size of the node is %d, then size of object. This print statement gives the total size in bytes occupied this object in the memory by using the size of function. So this is a whole code, and yeah, this is how we write a structure in C. Now, almost on system, integer takes the 4 bytes of the memory in C. But the size of the pointer depends on your system. Like if your system is the 32-bit, then pointers take the 4 bytes. And if it is a 64-bit, then pointers are 8 bytes. So it depends on the system. And as we use the pragma pack 1, it tells the compiler so to not insert the padding and gives the actual size of the node. So just save this program and just run it. We run this program using the uh, to compile and run this program we use the terminal. So just I am opening my terminal. So here is our command prompt. Just navigate the folder into which your code is. So cd series, then write gcc, then your file name, modesize.c -o my exe. Just then enter, then write my exe.exe. And here is the output of our file. So size of node is 8. So this is the way to compile and run your C program. If someone's system is 64-bit, then it gives the 16 bytes. So our system is 32-bit. So it gives the output as the 8-bit. So that's it about the size of the node. So we saw in this video the functions of the linked list, then call by value versus call by address, then basic pointer terminologies, and here is the code for the size of the node. So that's all for today. We'll meet in the next video. So if you like this video or found it helpful, then don't forget to give it a thumbs up and subscribe to my channel. It really motivates me to keep making more beginner friendly content like this. And if you are curious about how to actually use the node structure to build a linked list, check out the next video and we will be writing the code step by step. So thanks for watching and I'll see you in the next one. Until then, happy coding.